right. Lesson 7, reasoning about similarity with transformations. So let's look at this notice and wonder. I see nested triangles. I have one triangle inside of another. So what do you notice? What do you wonder? For these days, I wish we were in a classroom so you could really tell me what you notice and wonder, because these lessons, like, it doesn't matter where you're coming from, you're always going to notice something different than I do. Let's see. I noticed that the triangles, like, why I want to try, ooh, what happened? I noticed that triangle ADE and triangle ABC share a vertex. Okay, I noticed that when I look at it, and I noticed that when I write them down, right? I can say that the triangles are similar because the sides, excuse me, are proportional. So AE is 5, yet AC is 20, which means that's times 4. So if AD is 3, this should be 12, 9, 10, 11, 12, and it is. If this is 4, then that's 16. So it looks like my scale factor, if I'm going from the small one to the big one, is a 4. So they are similar. I don't wonder much of anything because we know a lot. I know that these are parallel. Yeah. I wish you were in the classroom. You'd tell me what you were wondering. All right. So sketch 2 triangles with all pairs of corresponding angles congruent and with all pairs of corresponding side lengths in the same proportion. All right, so I'm going to do this over, well, let's read the rest of it. Label your triangles ABC and DEF so that angle A is congruent to angle D, B, E, C, F. Label each side with its length. Do the 2 triangles you drew fit the definition of similar? Explain your reasoning. Switch sketches with your partner. Okay, I'm going to go to GeoGebra and draw some things. I'm going to go over here and read the question. So sketch 2 triangles with all pairs of corresponding angles congruent. I did not show that the angles are congruent. I can do that real quick. Oh, I don't want that. I'm doing angles. There we go. Why isn't it letting me do angles? Let's try these. That's weird. I don't know why it's not letting me measure the angles. Select 3 points or 2 lines. Cool. Okay. I could also do this. Let's get them so we can read them. Cool. All right. Sketch 2 triangles, all pair of coordinates and all pair of side lengths in the same proportion. Cool. If you look at the side lengths, 2.7 times 2 is 5.3, 5.1 times 2 is 10.2, 4.4 times 2 is 8.8. Life is grand. Label your triangles. Yep, we did step 2. Do the 2 triangles you do fit the definition of similar? Explain your reasoning. Yes. Okay, because, I'll write it down. Yes, because through a series of rigid,
Sorry,
I know.
I couldn't quite hear you. Could you please?
It thought I said its name. Rigid motion. Oops. and dilation, rigid motion dilation, I can transform one triangle to the other. And that's what we see. I have equal angles, and I could do a directed line segment. Let's try a real basic sketch here. I can do a translation through directed line segment, directed ray, A to A prime, and then a dilation with center A as a scale factor of 2. And all of the vertices will correspond with the others. Okay, coincide with the others. Sorry, wrong word. So directed line segment from A to A prime, and then a dilation scale factor of 2. And C would be on C prime, and B would be on B prime. Okay, and it would totally work. Oops. Yep. Okay. Invisible triangle similarity. So player 1, you are the transformer. Take the transformer card, because we've got a card thing again. Player 2, select the triangle card. Do not show it to anyone. Study the diagram to figure out which sides and angles correspond. Tell player 1 what you figured out. This is one of those things that I'm super sad because it's fun to do in class, but I have not figured out a way to do this one virtually. There's my tears, crying. All right, so if we look at this one, how could I do a series of transformations to show that triangle little one is the same as big one? All right, so I know that the angles are congruent, and then I know that the side lengths are proportional. That's what we're seeing here. So first I see that all 3 pairs of angles are congruent. And I also know that 3 pairs of sides are proportional. When I know this and I know that, those are the only things that I need to know to show that 2 triangles are similar. So it's really important to show that the 3 pairs of angles are congruent and the 3 pairs of sides are proportional. By this, I can show the fractions just like I did in the previous lesson. Therefore, I can say that the triangles are similar. Let's do this. Sequence of rigid motions. I can rotate, triangle, let's do CEB around center E 180 degrees. So that means that this line segment will be rotated onto this line segment. That's why I picked 180 degrees. I'm going all the way over there. And then I can dilate triangle CEB until C coincides with A. I would actually have to call it C prime at that point. And B prime coincides with D. So what I'm doing is rotating it until it looks like this. And this would be B prime, that would be C prime, and then I would dilate it a scale factor. I would say a scale factor of K, because K is there. A scale factor of K, and then they would show that the triangles are then congruent after that dilation. And that's it. Good job.